Hopefully you are. Welcome again to Dan Does Data. We're back here working on our self-driving car model. Our model is just finishing right now. And that's it. That's the entire stream. That's all it takes. No, I started the training this before the stream technically started because I wanted to have it finished, and it just happened to line up almost exactly for when the model was going to finish. So we are, for those who weren't here last week, we're building a model for a self-driving car using data from Grand Theft Auto 5. Data such as the images of what the car sees in front of it from like the graphics, how fast you're going, and what your acceleration is normalized. And we're just trying to figure out how should you steer, and should you be going forward, backwards, or standing still, braking in other words. Last week we had a model that seemed to be working. I realized we had a model that seemed to be working, but I got kind of tired of manipulating the data. You might recall, to read in this data, I had to read in the raw data in this HDF5 file format, which is fine. It's a good way to read in data and to store big data. But there was a way the data was not actually stored in a very compressed format. So I had to read all this. I had to convert the data into the right size images that I wanted for the right resolution, rescale everything. It was getting to be a pain. I was getting tired of it. So I said, fine, I'm going to shrink the data. And so now I can read in all the data and run my model with just a few lines right here. And that's what I've just done. So I'm saving it as NPZ files, which NumPy, that's how it saves files in a sort of platform independent way. They're not super compressed, but they are pretty much binary. So that's pretty nice. And the model just finished. What I've added from last week, what I've taken away, is also important. So I've added some regularization. And regularization, this W regularizer in Keras, is a way to penalize your model for having excessively large weights. And so the effect that this has is it helps you avoid overfitting, because the model gets to a point where the weights get so large that are just trying to fit a particular thing, it starts getting penalized for that and has to be more general and accept a larger loss to generalize. So I did that, and I also decided, you know what, I kind of arbitrarily decided on the number of dense layers here, so why don't I cut that down? I didn't try this with and without, so let's just try it without and see what happens. And we're still just trying to fit a steering model right now. We'll get to the gas model in a second, maybe later today. That had some issues that we worked on earlier. Anyway, we just built this model. Let me activate this. Oh boy, what's this? Faster create a function computing outputs given certain inputs. Is that provided input variable at index blah blah blah? It's not part of the computational graph. I disagree. I think it is. To make this warning into an error, I think it's just confused. It's just confused. I'm gonna be really annoyed if it's not. There we go. Yeah, that's normal. Those values are actually kind of large. We'll see what happens here. Oh my. This is different. This is slightly different. So the model values are supposed to be restricted between 0 and 1. And the blue is what the model is predicting. So as you can see, it's predicting some excessively large values. This model's all over the goddamn place. Holy crap. Wow, that regularization really threw things for a loop. That really wrecked things. And the way we're going to notice this, in case that graph, which was the real versus predicted values, let's make an animation. And so the red is the prediction, and the green is the actual value. And you can see, it's sort of matching, but this has got this severe list right. I have no idea why that is. That doesn't even make sense. It's all over the place right now. This is unfortunate. All right, so that didn't do too well. It is possible. We take a look at h.history. In Keras, this is the training. You can see how the loss improved. Oh my. So it's this last epoch, something went very, very wrong. But the validation loss actually wasn't too terrible. So whatever the It happened to do well on that part of the data. But that mean squared error actually got terrible in just that last epoch. Dang. I should have been paying attention to that when I was training. Yeah, there it is. Lost. Bam! Suddenly climbed. I should have stopped here. That's amazing. I did not think that was going to happen. Alright, here's what we're going to do. We're going to tell it to train 1 epoch. This should take about a minute. Yeah, look at that. Look at that. Look at that. Much better. This loss is entirely much more reasonable. I don't know why that happened to do that. That's wild. I've never seen that happen before. Where the loss is pretty, improving and then suddenly gets dramatically worse. And this isn't even the validation loss. This is the legitimate training loss. Maybe my learning rate is too large, which I am not setting somewhere. So I did change to RMS prop. So that could be part of it. And I apologize if someone's been in the chat. I didn't have that open. Let me do that now. There we go. Yes, so I can change optimizations. Optimization, not normalization, optimizers. Here we go. And I believe you can set the learning rate, yes. And I would do that up here. Say RMS equals, where is RMS prop? Right there. So you can set the learning rate by creating an optimizer object, RMS prop, and I say learning rate maybe 0.01. I don't recall what the default is. RMS prop. RMS prop, there we go. Lowercase that. Much better. Learning rate is actually default even smaller. Didn't expect that. Okay. At their default values, except learning rate, which can be freely tuned, yeah. So that's actually surprising. I wonder if it just got into a really funny state. Okay, so anyway, the loss is dramatically improved here. So that's just retraining the model for 1 more epoch. Not futzing around with the weights. Woo. Let's have a look-see at the model now. That might have just been unlucky. But that's still super strange. I did not expect that at all. If I had been saving the weights after every epoch, I could have compared the model and be like, oh yeah, it's getting better, 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 suddenly awful. It might have been like it was moving in a better direction perhaps, but it didn't quite get there yet. That is a possibility. This is making more sense. Okay. Hey, we're actually bounded between 0 and 1. What do you know? Again, the blue is our model's prediction. As you can see, it's not where it needs to be yet. Because the blue comes first, and blue is... Where's this line again? Yeah, predictions first, then targets. But we're off. You can see we're generally too low. And you're going to see that in the video here in a second. Let's do that. Let's show you the video. Yeah, the red, usually we're to the left a little bit. Whereas we should be pretty much balanced. So overall the model's a little biased. It's handling some strange situations pretty well though. Like when we're turning a lot, it handles that. But if it just went straight the whole time, it would actually be doing better. But yeah, this list, now it's listed to the left. But not super wrong, just generally wrong. That's so strange. Super weird. Maybe needs a little more training. Let's try just a little bit more training. We'll try another epoch here. I wanted to futz around with the learning rate. Let's try that. Optimizer RMS. There we go. Recompile the model. Let's try it now. I don't recall. We're going to see if the weights get reset when I do this. They might. You'll notice the loss starts out terrible if that is the case. It is. Okay, so it had to recompute the weights. But you see how awful this loss is when you initially start. That is just essentially totally random what values you're computing, and it relatively quickly gets on the right track. All right, let's bring over some of the gas model, the gas.py. how much we want to... I guess that's almost the same. How much do you want to accelerate? Acceleration model. There we go. Do that. I don't need to read data in again. I already did that. Yeah. That is more or less correct. Except, look at this loss. Why is the validation loss? Like, so there's 1/10 as much validation data, but there's no reason for it to be that messed up. That's super strange. To me, that just says like it's still basically random. Train again. Train more. But like now the loss is totally hunky-dory. Like as opposed to the closing loss here. What changed in the last couple parameters? So there is one thing in this data set. I know there's a scene for, I don't know, 20 to 30 seconds or whatever in what it amounts to a couple minutes of footage. Where the car is just like stuck on another car and it can't figure out how to get off. Yeah, this. So I wonder if I just have some bad data points, if that's what the problem is. And I'm turning on shuffle. Maybe I should turn off shuffle, and I might just need to rip out those data points, figure out what file that's in, tear it out. Oh my gosh, but that could be the problem. Like when that's near the end, those kind of data points. Actually, I think that maybe that's what it is. That might just be terrible data to be training on. Also, the car is stuck on another car and it's trying to turn the wrong way to get unstuck. Like the target value, the target steering is the wrong way. And that's because there was a computer in control of this car originally. Part of the problem. That's alright. Okay, so let's try to find out which one is the bad one. And I believe we can do this. I'm going to do something else here too. Print I. So we're going to get, we don't need to get points again. We're going to plot it. And the whole time I'm doing this, so I'm going to leave this on for a bit. It takes a little, you know what, forget it. No. I know it doesn't start at the beginning. So you can say what the range is that you want to plot, which indices from your array. Let me start at 100. There we go. Let's do that. Oh, nope. That's not what I wanted. Like that. So we're starting at 100. We go into this tunnel. We're still listing left. There's a car. It's like, whoa, what do I do? Another car. Yeah, still listing left. Come on. I distinctly remember this, and it was so weird. Good time for questions while we're watching video to try to figure out what's going wrong. We're playing 10 frames a second here, which isn't that many. But this is not the best platform for playing video, so it's not the kind of thing that you crank up to like 100 frames per second just to find the thing you're looking for. Is it near the end? Alright, we're at 500. So 10 frames per second, 100 seconds is a little under 2 minutes of just watching the video is all it's going to take. I feel like it was soon. Feel like it was very soon. Come on, come on. All these cars. Also, this data you'll notice is very like jittery. It'll just like jump ahead 20 or 30 frames at various times. I don't know why that is. It might have been during when it was collected. It's not so that those frames were just lost, that information couldn't be gathered. Yeah, this person pulls off to the side of the road for whatever reason. Alright, we're almost through the whole... There. Oh, we came back here. Yeah, I know this video. This is familiar. You might remember this type of scene from the first set of videos. We turned crazy. I think there's only 1,000 of these frames. We go left, we go right. Here we go. So at frame 1,000, bad things happen. All right, this can be fixed then. And I'm betting it's about 100 frames of terrible things. Longer. So this is the problem I was talking about. And you know, our model's doing a halfway decent job of modeling this. But like, there's zero change in the image, essentially. There's no change in the speed and the acceleration. Just from points 1000 to about 1250. Okay. So we learned something important today. That frames 1000 through 1250 are bad frames. Whoa. So, numpy.array all images. All images is a list. Yeah, there we go. So this is my script for reading the data and shrinking it. So we're gonna go to 1000. We're going to add all images of 1250 to the end. And we'll do this business for all of these. So we're just going to rip out some data. We're saying that data is garbage. That is not representative of the kind of driving that we want. And you might be tempted to say, oh, but it's part of the model, it's part of our data. But that is not the right kind of data. That is a problem in the data. In looking at the data, #1 rule of any machine learning, statistics, anything like that. So that is what we're going to do. Okay. So temporarily, what I want to do is I want to say images equals images 1000, hang on, images 1000 plus images of 1250. Yeah, you can't do that. But I can, I bet, say numpy.concatenates those things. Nope. Okay. So how are we gonna do this in the proper way? One of these days, man, one of these days. NumPy.concatenate, I believe you can give it an axis, maybe? Axis along which arrays will be joined. 0, so maybe axis equals 1. Oh, no, oh, no, not plus. Nope, just this. Only length 1 arrays can be converted to Python scalars. Do I give it a list of arrays? Is that the problem? Yes. That is the problem. Some things in NumPy it expects a list of arrays, some things it just wants the arrays in separate arguments. That's something that always irritated me. Okay. So images 2. And this is going to be speedx. Where's my data read in? Over here. Speedx, which is our input speed and acceleration. Speedx. Speedx2. And finally, we got to do our targets, which is our desired output steering angle and the acceleration, whether you want to gas or go in reverse. Go forward or backwards. Goes forwards, backwards, and turns. I was excited when my first car did all those things. I guess the first car I bought. First car I owned, it did some of those things, some of the time. How good it was, you know, it seemed better. Alright, so I still have some 10,000 data points. So that's not too bad. We lost, well, 250 data points. Also, I would not be surprised. Dang, thought that was setting an array element with a sequence. What? Do I have preds? Is that a thing I have? Then that should work just fine. Do I have targets? Oh, I reset targets, didn't I? I did. I'm a bad person. I'm a bad person. Alright, well, whatever. So I'm going to say numpy.saveZ data/images array .npz images 2. There we go. Now we're going to say speedx2. So we're just ripping out that garbage data in favor of good data. And I forgot to rename targets to targets2 because I'm a horrible person. So it goes. So it goes. Images equals images2, and speedx equals speedx2 now. Okay, so now we can actually train our model proper like. So let's give it 1 epoch to go. I missed the target. Yeah, I know. We're missing a lot of targets in this. Oh gosh, can I even see through all that? Yep, therein lies the problem. Oh, I didn't mean to. Oh gosh. So the loss is still, it's going down. It's getting better. It's still super high though. Might need more than 1 epoch to handle this. We've got less data now. We'll have about 200, what do you think? 10% of that is 25. Yeah, 225 fewer data points to train on, 25 fewer points to validate on. That's life, you know? Okay, that loss is insanely high. That's not right. Why is the validation loss is fine, because the validation values are not insane. Is there something wrong going on in this targeting set here? That's very strange. W. Are some of my weights way out of control? No, they look relatively normal. Relatively well scaled. Not terrible. Not super tiny. These final values are all numbers that do things. Okay. Let's see what it does here. I don't know why that's complaining at me. That to me is strange. It says it doesn't like this model, which I think is weird. Alright, shouldn't take so long. It's not that big of a model. Although it's not, the model size is dominated by that first layer. And the model's predicting essentially the same numbers all the time. Let's have a look-see. It is predicting not exactly the same number, it's different in these last few significant digits, but basically the same number. If you do that, you do this, you see those numbers are almost the same, which is not really what we want. But now the loss is fine. So at what point does the model become crap? Because I suspect the loss is increasing here, and then it suddenly jumps. I suspect there's still garbage. There's got to be some garbage data point in there still. Like, why would the loss suddenly be 25 million? That doesn't make sense. Like, is one of my targets totally jacked? Maybe. I didn't think so. I'll let this finish because it only takes under 10 seconds, but that's very strange that I've got loss of 25 million. Although I guess I've got this regularizer which is doing stuff. So that's increasing my loss. But that shouldn't be increasing my loss that much. Yeah, it's still 10 million? What the hell? This makes no sense. Targets. Targets. No, what? What is this bullshit? Oh, no, that's right. Because that's the second column. If I say targets of everything in the first column, that's fine. Okay. And I'm building the correct model, right? Yeah. I'm building the model where I use that column. That's so strange. So strange. Let's not shuffle. I'll tell you what. Let me see what happens here. Where does the loss get insane? This is what I want to find out. Loss jumps, makes a jump here. About 12 something. I will be right back. 1 second. I need to... Whoa. We don't have scenes in here. Let's get scene 1, which is just blank. Screw it. We'll just show it right there. 1 second. I'll be right back. Sorry about that. Now I missed. Got a kitchen timer going off. Why? So I missed where it went. Where it went crazy here. Now it's going crazy right at the beginning. Madness. This is madness. Let me recompile the model. I give up on RMS. I can blame RMS, or I can blame the regularization for my woes. Okay, that starts crazy, which, you know, maybe I'm willing to tolerate, and slowly improves. That's so strange, so strange. I feel like I've never had this problem before, even like with this specific data, that the loss would suddenly go nuts. So it must be the regularization or the optimizer. That must be the problem. Let me lower the learning rate here. Maybe I should not have increased the learning rate. I mean, I wanted to decrease it to begin with. But that's wild. That's absolutely wild. Yeah, okay, that's just jacked. I cut the learning rate down and redo this stuff. What happens now? You're still in the dark. Oh my gosh, I'm very sorry. Thank you for fixing that. Thanks for letting me know. That was all just ignore the man behind the curtain. Alright, that jumped at about position 4,000. So maybe the data there is a little wacky. But it didn't skyrocket. It was only like, you know, jumped to 100 or so. So there's something weird going on in the data, which is totally acceptable. Weird things happen. Okay. Still about 100, still about 100, still about 100. Maybe the learning... Okay. I perhaps was too brash and increased the learning rate too soon. Still, a loss of around 100 is still bad. But if I train one more... So it starts fine. And then it suddenly jacks. What the hell? This is new. This I have not encountered before. This is absolutely wacky. I have not encountered. We're killing that. All right, we're gonna go back to Adam. Yeah, Adam was the optimizer I was using before. Let's bring that up. Usage of optimizers. I just want a list of optimizers, buddy. In fact, I think it's at the top here. Adam. There we go. Alright, we're going to kill whatever information we had. Adam, learning rate equals 0.001. That should be fine. Float. Greater than equals 0. That's default. Okay, so that's all hunky-dory. You know what? Let's just kill it with fire. Kill it with fire sometimes is what you got to do. We're just going to kill that whole IPython session, come back here. Read in the data, or read in our modules, read in our model. Sometimes you gotta kill it with fire. That's the only option. There we go. New model. Let's train it one time. I'm not shuffling, because I want to see when it goes crazy. What happens? What happens? I might take off the regularization. That might have to be what happens. That might be a weird... It might just not play well with this data. I might still have garbage data. Any number of things. Could be totally wrong. Okay, the loss starting off kind of high, totally reasonable. I expect that. I expect the model to start garbage. And you know, it's slowly improving. Things are happening. I love this interactive interface of the progress bar. So I can observe what's happening. And know how long I've got left. This is wonderful. I give mad props to the Keras developer for including this, as this is the verbose mode. So good. Alright, you know, one epic we don't expect a good model, right? But should get a model that's not insane. I mean, it might be pretty bad. It's probably pretty bad. But let's see. What the hell is with that? Disable completely, use on input, ignore. Let's ask to create a function. Ask to create a function computing outputs given certain inputs, but the provided input variable index 2 is not. Hang on. Hang on. I might have done something really wrong. When I futz with my model, maybe I screwed something up, because I took out these layers here. That could be what futzed up my model here, but I don't think so. This is ED1. This is accepting in ED1. And in my typical model, I believe I'm doing something analogous, just ED3 is all. So I don't think that's the problem. Don't think that's the issue. These wild... What? Alright, sometimes the values are a little negative. That happens from time to time. What the hell? That doesn't make any sense. Why would you be doing that? Like, not only is the model, like, wrong, but it's wrong in this weird, consistent way. This is what the strangest thing to me is. That's so weird. And we're halfway through the stream, and we've gotten nowhere. Apparently I've broken everything. I want to give it one more epic to do something sane. Maybe I need to drag down the regularization rate. Maybe that's way too high. That could be part of the problem. I'm penalizing my model way too much, possibly. So I mean, I just use 0.01 as sort of a, that's what I typically start at. If I'm mucking around with regularization, that's the default. It's easy to do. But wow, that was, maybe I needed those extra layers too. I wouldn't think I'd need them. I just thought I might get a better or worse model if I did. I did not expect the model to essentially break down completely. Rick Anderson made it. Thanks for showing up, Rick. Don't worry if you didn't see the stream earlier. Everything was fine. Everything was fine. Don't worry. Everything is fine. I know exactly what I'm looking for. No, that's not what I'm looking for. This is what I'm looking for. Everything is fine. I'll just leave that up here. Everything is fine. Oh look, oh, this is actually sane. Hang on. Yeah, just ignore the past half hour. Assume I start right here. That's a much easier. This is still, I didn't make new predictions. That's the problem. New predictions. There we go. Okay. Can I get a progress bar and predict? That's really what I need. Or I should just start predicting the first, like, 10% or something. Preds. Oh, look at that. Those look like numbers. Okay. This is making a little more... This is getting under control a little bit. Still a little wild. Notice we still have values up to down to -1. When we went no values below 0. You know, but we're not really... That I'm willing to live with. This, like, you know, drive all over the place wherever you feel like. That's problematic. You know, that's a bit of a problem. Not a fan of that. Not a fan. Okay. This feels like it's improving though if I give it one more epic. Like one more epic. Just one more epic, man. That's all I need. The loss isn't going crazy anymore. So I feel like we're doing the right thing. We're regularizing too much perhaps before. I think that was probably part of the problem. Maybe RMS prop does something strange too. The learning rate was probably in air to do. Oh no, the loss is climbing. Oh no. Alright, going back down, going back down. This is like too stressful. I really shouldn't be watching this. I should just let the model do its thing. See how it shows up at the end. Oh, shuffle I should definitely turn back on though. Shuffle equals true. Now that it's no longer being insane. Even if the model is not necessarily good, I'd strongly prefer it to be reasonable. Alright, here we go. And then whatever this model is, we're going to animate it. Someone just got here. What dataset are we using? We're using the deepdrive.io dataset. So if you go to deepdrive.io, this is a bunch of footage and vehicle information collected in Grand Theft Auto 5. Of the, I think the computer, the AI in the game is driving, and it does a pretty reasonable job. But you get the steering position, you get the acceleration, you get like how much the car is spinning, its speed, and the actual video of what the car sees in the car's perspective. And you'll see what that looks like in just a second. All right, this is definitely improving. This is definitely improving. It's still all over the place, but, and you're going to see that here in just a second how all over the place it is. Okay. Let's make our pretty picture. So the red is what the model is predicting. And you'll notice, hang on. I don't need to be printing out the eye every time. That was debugging. Right. So the red is the model prediction and the green is the true value, how the car is trying to steer. And so you'll notice right now, the model's kind of all over the place. So it's got a lot of learning to do. I think it's tracking a few particular scenes reasonably well. And like those might be some really weird scenes where like just holding steady is kind of the right thing to do. It's not insane. It's like we're tilting a little to the left. And it's pointing to the left. But it's certainly not great. Definitely not great. This model has a lot of learning left to do. But it's starting to get on the right track. And it's only trained for like 3 epochs at this point with a pretty small learning rate. Because when the learning rate was large and the regularization was large, it got in trouble. And with that regularization, that's going to slow down the learning as well. But it keeps us from learning really bad things. Okay, so that's interesting. So I think I'm going to declare that victory. I'm going to save those weights that I have for now. And let's take a look at the gas model. That's something else I want to try. And how I want to do this is, let's engage the acceleration right there. Let me grab all this stuff. Model gas. And our output is going to be, not steer. Ugh, mucked this up now, didn't I? Excel, that's what I want. There we go. So we're trying to predict a class output, whether to go forward, to stop, or to go backwards. Which we might be fiddling with that. We might change that to like a floating point value of how much forward and how far backwards you want to go. Although it's like sometimes you just want to stop and brake when that's semantically different from other stuff. EA1, is that correct? Yes, that is correct. Let me steal these 2 lines. There we go. And so this is coming off of ED1 right now. There we go. And we got to add our regularization. Don't want to go nowheres without our regularization. Gots to happen. Okay. There we go. So we add these layers, and we will just make a new model. So we're starting with the weights that we had already made, which is, you know, maybe dangerous. Oh no, we're going to recompile. So we're fine. We're fine. Don't worry. Everything is fine. We could have jacked in those weights anyway. Question from the audience. Would regularization keep the steering near the mean or near 0? What if it has the effect of biasing the car to turn one way? That's an interesting question. I think by default it would not bias it to 0 necessarily. It would, because we're not putting a regularizer on the bias term of the model. So every one of these layers has a bias term, which is just a certain constant that you're adding into the model. And on the last layer, hang on, let me get the, on the last layer, our bias term is this. So it looks like we're slightly, almost 0 in whatever the bias term is. So that could be what's happening. You might suspect that the bias term ought to be like 0.5, depending on what values are coming out of the rest of your model. All right, Rick was thinking he wants an output command string. Steer, M1 direction, M1 speed. What are M1 and M2? M2. Oh, is that the different tires? The same values to simulate solid rear axle. Ah, yes. So that is an option. If, for example, you're going around a turn, one wheel doesn't need to travel as far as the other. So you could try to, I'll be honest, the model is probably not going to get to that point in the next week or two. So this everything is supposed to be done like in the next week or so. I don't know if you've noticed, this isn't working yet. We're not there yet. We'll get there. We'll get there. Make all that. Oh, I don't want 100 epics. No, no, no. I just want to see what's going on. I just want to see what's happening. We'll save the 100 epics for when I'm computing off stream. Does this even work? Does this even work? That's always the question. Almost. The first time you run the model, it's got to compile. It takes forever. It's a big pain in the neck. Yada, yada, yada. All right. But I do want to make some predictions. Pred's gas. And I had somewhere I was futzing with a model to display the gas in a better way. Is that here? This looks sort of like what I was doing with that. Whether I'm going forward or backward or something. Is that different from this model? Yeah, I think it is. All right. Did the model do something insane? That is the question. Gosh. Oh, I don't necessarily want to predict. I really don't know why I'm getting this warning all the time. Input variable at index 2 is not part of the computational graph. SpeedX and images. It really should be. Is my model jacked up? Is that the problem? Input shape 2, and when I go to fit, I fit with SpeedX and images. And when I do to predict, it's SpeedX and images. No, that should be fine. That should not be a problem. Actually, depending on certain inputs. If I had an input variable at index 2, there is no variable at index 2. That doesn't exist. Ah, but Rick's saying that he will collect more data from the old race. That will be awesome. I will love to have that. I mean, whatever we can get. Pred's gas. Alright, yeah, so that's a thing. Let me get the actual... Oh. Yeah, no. I thought I... You know, sometimes I just get confused about where I am in this model. There we go. So let's plot the Pred's gas against targets 1. So Pred's gas... That doesn't actually make sense. Because I should be predicting like a class here. 0, 1, or 2. That doesn't make sense. That doesn't make sense at all. That's just giving me some probability or something. Model gas. Predict. Oh, come on. Output predictions for the input samples. Processing the samples in a batched way. NumPy array predictions. Oh, hang on. I'm an idiot. Doop, doop, doop. I have 3 classes in my model. That would explain my problem. Targets all, comma 1. Also, I need to change that to dang categorical variable. I did a lot of things wrong here in this gas model that I actually did close to correct when I was doing it the complicated way here. When I'm doing my fit over here, I'd say to categorical. To categorical, there we go. I don't know if that's it over here, it's not, there we go. So, okay. Where am I? One more, there we go. To categorical. So we were doing some weird binary, we were doing something wrong. Something very, very wrong. That's what we were doing. I'm surprised the model made as much sense as it did. We need to make this again. Let's just do this again. Let's just remake all that. To categorical is not defined because I didn't actually run that line. There we go. Okay. Visibility. Visible deprecation warning. Using a non-integer number instead of an integer rules out an error in the future. Buddy, it's fine. Everything is fine. We're using to categorical. Maybe it's a problem in to categorical. It is, because it's in numpy utils, and that's where to categorical lives. It's fine. Everything is fine. Let me explain. This is fine. Okay, and then hopefully our model will be able to predict our actual output classes, which is what we'll want. And I'll just plot those out as the actual values. I don't really care. So it's going to predict a bunch of probabilities for our various classes at each data point, and it will assign the class, whichever class has the greatest probability at a particular point, it will assign to that class. So it's giving us some loss. Oh, we shoot. I do not want to be using mean squared error. Categorical cross entropy. So again, I continue to do things wrong. So once again, allow me to redo this model. The number of times at which I'm trying to fix this. The danger of doing data live, as always. Ugh. Okay. Now it should be working right. Hopefully. We've got some accuracy here. And you'll note that it's coming up with like 80% or whatever, probably because 80% of it, the accuracy is to just go straight, hit the gas. Which again is fine. It's a totally fine model. Nothing wrong with that model. That might just be our default model of go straight, go for it, hit the gas all the time. Because this vehicle does not go very fast. And, you know, we're in a race, so that's kind of what we want to do. Go real fast. Go fast, turn right or left. Probably right. Alright, okay. It's bouncing around 81%. I highly suspect that this data set is 81%. Just go straight. And our model is predicting go straight all the time. I'm calling it right now before it even gets to that. Just because it doesn't have enough representations of the rest of the model. Let's see what happens. Let's see what it is. There we go. Yes, so now we have a probability for each class. You'll notice it's like, oh yeah, about 88% this, 1% this. What is this? Oh no, and like 12% class 1, and almost never stop. That's not surprising at all. Not predict. Thought there was some other way you could predict to say, give me the actual classes. Alright, but I can do that. NumPy.argmax. Preds gas. Axis equals 1. Does that do what I want? I think that does what I want. Okay. So let's do that. Apply.r. So we're just going to take whichever class has the maximum probability at any given data point. Axis equals 1. There we go. And instead of recomputing it again, we'll just make it right there. And now we should be able to plot this. And yes, well, no, it actually isn't all zero. I give the model credit. That is more than I expected. So of course, in our actual data, wow, this actual data is more spread out than I thought. I thought it was all very strictly run, but it's actually fairly well distributed. So 0.5 means, hang on. Something is fishy here. Something's fishy. Targets 1. Targets 1. Something's fishy. Fred's guess. Ah! I was doing Freds.reshape. One of these days. One of these days! Alright, I don't even think I need that anymore, actually. There we go. No, it didn't like that so much. That's the targets. What if we just did? What the heck? Just the Pretz gas. That's all I want to see. There we go. Oh. This is better than I thought this model was going to do. I gotta be honest. This is actually better. Like, it is saying, hey, go forward sometimes. Or, go forward most of the time, sure. Stop sometimes. Hey, even back up once. Wow. I'm going to save the weights from this model. That's... I don't know how actually good this is. But the fact that it's not all zero all the time, that I was wrong about that, that gives me some hope for the future. Gas simple. Gas simple. There we go. That's, alright, that's pretty cool. If nothing else, that's what we got for this week. We have a gas model that isn't always, and that was one epic. Look at that, one epic. We were able to make that work. Amazing. It blows my mind that these things ever work. Let's say you train for another epic, that's going to be twice as good, right? That's got to be what it is. No. So that's, I'm actually impressed that that did something, and did something sane. And even though, yeah, it's only one epic, that first epic you can often get a lot of predictive power looking at the data just once. And if you think of traditional linear regression with a limited data set and a limited number of variables, you can snap your fingers and solve for that directly using some linear algebra. And so you sort of look at the data once, and you compute exactly what the answer should be. I mean, here, you're using some kind of gradient descent or other iterative algorithm, and so you don't have that luxury. So you have to look at the data multiple times to make sure you pick up all the features. But you get a lot of energy out of that first prediction. All right, let's do this again. Let's see what happens. Let's see if I can animate this the way I like. Let's just see if I can do that. Oh boy. Oh boy, oh boy, oh boy, oh boy. Let's guess. There we go. 1. I don't know why that needs to be 0. That's just an array. Fred's guess, right? Yeah, there we go. Oh, dang it. I didn't need to do that. Did not need to do that. Well, yeah. Actually, what I should do... fig equals plot.figure. should say fig.plot that, and fig.plot of numpy.2 categorical is my magic thing. Yeah, 2 categorical. No, not 2 categorical, just direct. All those things in one. Let's see if this works. Figure object is no attribute plot. I thought I could get away with that. Thought I could get away with it. Let's see if I can do that. Oh! It wants to make line plots. Line plots are not what I want. Line plots are not what I want. I want you to use X's. I want you to use dots. What happens when I do that? Alright. Well, this isn't the perfect. There are better ways to visualize this for sure. You can see we're missing all these reverses, and we're missing a good set of these over here. But we're doing halfway decent. Again, not as obvious. What if I just zoom in? Just get rid of all that. How are we doing when we just look at this? You know, we're doing okay. We're doing okay. That 80% accuracy or whatever it was. Oh, I should look at the confusion matrix. That's what I should look at. Scalar metrics as metrics. Metrics dot confusion matrix. How does this go again? Y true, Y prediction. Okay. Targets 1, comma, Reds gas. I believe that's what we want. There we go. So this is, of course, the x-axis, I believe, is the truth. And the y-axis is our prediction. Sorry, not axis. You know what, let me just look it up again. I always get confused by this. Returns, array, shape, n classes, confusion matrix. Yeah, well, that's cute. Anyway, you can see we get, 6,000 out of probably, oh dang, those numbers are almost the same. I can't even tell easily. No, the row must be the true class. Because it's, yes, there are truly like 40 times when you need to stop. Because otherwise there would be no times when you need to go backwards. But we never predict backwards? That's not true. It definitely, oh, maybe it is true. Maybe that is the way it is now. So we had 1 before and we lost it. Alright. So it's predicting never go backwards. You know, to be fair, there's only 35 instances telling it to go backwards. So that's not crazy that it never gets to that. Compared to like 3,000 instances of come to a full stop. And it gets 2/3 of those. And compared with like 7,500 instances of go forward, it gets a strong percentage of those. This is actually, this model I think got worse on accuracy. Metrics dot, let me just show H dot history. Yes, our overall accuracy was 83%. The validation accuracy was only 61% though. Not great. You'd like your card to not be wrong 1/5 of the time on should it be going forwards, backwards, or stopping. Something that, you know, something that's important for your car. But this is not crazy for 2 epochs of training to have a model that performs that poorly, I guess. I'm sort of willing to live with that. All right, hang on. Let me. Oh, there we go. Not P, comma P. First one is the row. So I want you to be at 48 times I. No. 12 times I. And position 32. 12 times I in position 32. Let's see if we can get this to work right. Oh, no. 24, yeah, 48. Let's just do this real quick. See if this even works. Clearly I did something wrong here. This is not what I meant to do. Not what I meant to do at all. This is the 24, that's the 48. Alright, so I got these mixed up. 24, 48. 63. 63. 24. Alright, we're just going to try to get this visualization going and then we'll be done. 48. And this is going to be P times 12. This is going to be T times 12. You know, some things are changing. It's breaking sometimes. As in, it's trying to slow down. Is that the model? No, that's the truth. The truth is it's breaking more often than the model is predicting. Alright, well that's interesting. Interesting to know. Plus 12. One more thing. Always just one more epic. One more epic. Right? There we go. That's just a little less crazy. And maybe I should put these things right next to each other. We see most of the time it's just go forward. And you know, it's say, hey, break for a second real quick. And the model's capturing that to a certain degree. Okay, well that's interesting. I think that's where we're going to call it tonight. So I want to thank everybody for coming out and being patient as we work through models that do really weird things. We learned important lessons about regularization and how we need to be careful when we're setting those values. But we got a gas model that does something. Getting something to do something is always the first step towards building a good model. So that's all we got. Don't forget to keep your helmet on. Stay safe in the data mines. Have a good night.